Good news is we have a very good panel here. I think you've seen some of these speakers already today. I'm delighted that they are here joining us because I don't know a huge amount about natural language processing, but I'm glad that they all do. So if you wouldn't mind, I'll start by just asking if you could give us a quick introduction. Yimei, you could start with yourself, please.
Hi, my name is Yimei. I am the Global Head of Research Technology at Morgan Stanley. My team works very closely with our research analyst team to help our clients generate alpha by leveraging machine learning and natural language processing, which is what we're talking about today.
Excellent. Sounds good. Gordon, please.
So I'm a teacher and also a trader. So I teach at NYU and the Quran Institute and also over at the Tannen School and also at Baruch College in the MFE program and at Rutgers in the Department of Statistics. So I'm interested in applications of advanced statistics to trading. And I think that modern machine learning is essentially advanced statistics. So you can call it machine learning if you like. As a day job, I'm a quant trader, so we compete with the likes of 2 Sigma and whatnot.
Excellent. Robert, please introduce yourself.
Rob Marsh, recently of Kensho. Before that, I had a long career at Tudor Investments. Now doing some work actually helping out Just Capital in an advisory role, so very interested in some of the stuff you're just talking about. I suggest I probably represent the layperson's view here on the panel. I'm the one in the meeting that starts off a product saying, no, it can't be that difficult, really. And at the end says, is this the best we can do?
Sounds good. And Javed, please.
Javed Jussa. I head up quantitative research and strategies at Wolfe Research.
Excellent. Great. Okay, so I thought let's just sort of set the stage. Gordon, maybe you could take the first question. Can you just give us your view? What is and what should we be thinking about with regards to natural language processing and sort of how it fits within the family of AI capabilities?
Sure. So I think of it as also within the framework of reinforcement learning, right? So in reinforcement learning, the goal is typically to build an autonomous agent that can select the best action to maximize some notion of cumulative reward or gain, right? But to do that, it has to know what state of the world it's in, and it has to know what the available actions are, right? So just to take a random example, right? Suppose you see a text news announcement that says, tickets are about to sell out relatively soon. Then the optimal action, if your goal is to attend the concert, is to buy your ticket more quickly, right? So and that's an example where natural language processing applied to that text it tells you what state of the world you're in, namely a state of scarcity of tickets. And that then informs the agent's decision to take the optimal action to attain its goal. So now, there are a lot of ways to do that, right? So everything from sentiment scoring to part of speech detection and named entity recognition, those are all necessary for building up a representation of the true information in the text that then tells you what state of the world you're in and what action you should take.
Okay, and I guess, Robert, this is where the notion of processing of the language and segmenting and so on differs from, say, understanding. Can you give us your thought on how that is the next level or so?
Oh, sure, I'll try. And again, I acknowledge that it may be a false distinction between processing and understanding. I think from a discretionary or humans interaction with the tools and the output, the bar is a lot higher than it would be for, let's say, quantitative trading. Mm-hmm. And that's where I think the understanding comes in. I viewed NLP as a bit, and this is an old metaphor, so I'm dating myself, but is the digging of the trenches, laying the pipe, the cable, bringing it to the house, where the understanding represents that last mile in. Get it to the user, the human, so they could actually do something with it.
Javed, do you have any thoughts on sort of NLP and processing for really getting meaning out of the text?
Yeah, no, and agree with the other two, our other two speakers. Yeah, so I mean, we look at it in a little bit different light, but essentially we just want to get features out of it. So ours is maybe a little bit biased because we're looking at features that could probably explain stock performance.
Right.
So ours is very applicable, but it depends upon the use case and the context. Some managers might want it to apply NLP to be able to summarize a filing or a call, a company call, or just to get a better understanding or summary of certain text. You might be a lawyer and you want to go through all your contracts. And if you've ever worked with lawyers before, they have a lot of files and contracts and very little computer technology. So NLP for them might be a way of not necessarily looking for alpha, of course, but maybe just organizing and structuring their contracts. So yeah, I guess it all depends upon the context.
Okay, so that's a good point. So Yimei, just can you give us some other ideas, and maybe everybody throw them out, in the financial services industry? What are the types of areas where we would want to see NLP being used, and where it can really add value?
So, of course, you heard throughout today the multiple different use cases, be it extracting information, sentiment analysis, et cetera, et cetera. So in Morgan Stanley, of course, the goal of our research is to help our client to generate alpha. The way we do that is by providing fundamental research, quantitative research, and by leveraging data and machine learning, deep learning. So one of the examples I want to give to you is that most recently we create a trading strategy based on sentiment model that use our research reports. So what we did there is, as you know, our research analysts, they do a lot of research. And the way they convey the research result is by publishing research report, right? But in the research report, there are tons of insight in that, but the quantitative strategists that cannot use it because it's a text, it's not very easily consumable. Unlike rating changes or price target changes, those are numerical, right? How do you consume the insight our research analysts produce in those reports is a pretty big question. So what we did was that we create a sentiment model that use deep learning and natural language processing based on our research report. So the sentiment model generates a sentiment score, and our sector quant did some analysis, and just based on sentiment score, the signal is not strong enough. So our sector quants then build a trading strategy using the sentiment score and overlay the price target changes. The trading strategy outperformed S&P. So how do we come up with this sentiment analysis model? What we did was we collaborated with our research analysts and sector quants and, of course, my team, data scientists and data engineer. So we take sentences out of our research report. We use the sentences as the records for sentiment training. So we label each sentence as positive, negative, or neutral. We create about 6,000 different records completed based on our own research and to generate that sentiment model. Of course, there are multiple iterations of training of that model. So in the end, we were able to reach the out-of-sample accuracy of the model around 80%. And of course, the trading strategy based on the model score and overlay with price target revision is it beats the S&P. So this gives you examples we're talking about today. How do you leverage your own data? We're leveraging our own data, which is our research report. We're leveraging our own expertise, which is our research analysts, our sector quants, our data scientists, and data engineer, and we're leveraging your NLP,
yes,
deep learning.
Okay, and do you put a confidence score on top of the score? So if you think it's an 80% hit, are you plus or minus? Are you giving people some extra level of confidence
So,
in?
well, the sentiment score is really whether the model is confident enough around the sentiment or not. So if you get 90% of the score, that means model is confident that research report signal is positive. If the model say negative 70, that means model thinks the sentiment is negative. So
okay. Okay. Gordon, when you've been doing a lot in this space, what are the underlying technologies that you've typically implemented and used, particularly on language processing? So what technology do you should everybody baseline their platforms on? And is it off the shelf, or have you had to build a lot of this yourself?
Well, Ravenpack's great.
Yeah.
But if you mean so on top of that, yeah, I mean we do build a lot ourselves, right? So I mean quite generally, we need our code to be very, very robust, and for it to sort of find errors itself, or for the compiler to find errors, or for unit tests to find errors. So from that perspective, we like structured, object-oriented languages, strongly typed languages like Java and C++.
Yeah.
And I've often found, and this may just be my own personal preference, but I've often found that let's say you go to use some off-the-shelf toolkit like scikit-learn or TensorFlow or whatever it is. Yeah. Invariably, there's a whole lot of parameters and settings that govern how it works. Yes. Various options that you have to get more or less right. And by the time you invest the time and energy to learn what all those options do and somebody else's notation for the model,
yeah.
And
you could have written it yourself.
Yeah, and if you'd written it yourself, if you couldn't have written it yourself, you probably have no business using the prepackaged tool. Okay. And if you could have, then by the time you do that, you'll know exactly what are the options that you can tweak to make it do its thing.
Okay, so that's interesting. So it sounds like the technology you like to build, but you source content from other players as well, who might have done their own analysis and their own processing, and feed that into yours. Ravenpack, obviously, is an example, yeah?
Yeah, that's a pretty accurate summary.
Okay. So Robert, what other data sets or content should people in our industry be actually trying to source and apply some of this analysis to, in your view?
Well, I think Yimei has an advantage in that.
Yeah.
I think one of the greatest source is the research and content that comes from Wall Street itself, because it's already very contextualized. Because in the experiences I've had, in a lot of the efforts, things break down because the data training sets really aren't contextualized well enough.
Okay.
And if you look at the dealer research, it's right there.
Yeah.
But it's inaccessible. Also, I think in form of content, so much good training data and training sets are in PDFs, which is difficult to access. So much of it is in verbal. I mean, if you could get all the interviews, all the podcasts, and get them down in text and tagged and all of that, I think everyone's job here would be a lot easier.
Now, would you do principal component analysis for that, or independent?
Yours?
I tend to agree. I think another way of saying it, and I completely agree with what you're saying, is maybe your best data source is your own data.
Very true.
And I think Morgan Stanley was quite a unique way of doing it, sort of manually tagging it. It might you probably have more skill in that as well. But there's also always a trade-off. Why would you go to hundreds of thousands of websites if you can get data from Ravenpack, right?
Right.
Unless you have a specific skill or a niche in that.
Yeah.
There's always trade-offs, because if everyone's getting a data set, then you're basically getting what everyone's getting. But there's also also a trade-off in the fact if you can get some data set that's, the NLP algorithms may be sort of more straightforward, but actually getting the data is very complex. So if you're trying to get a data source, if you're trying to sectionize it, tokenize it, do all the stemming, that could be quite complex. So, but that more complex data might have some more alpha. Irrespective of what you think about the signal-to-noise ratio. So there's always a trade-off. I think it depends upon a lot of the skill set you have and the manpower you have.
Right.
Yeah, I would add that what you said also, in this room you guys are probably all quant, right? So what we realize is that just quantitative analysis may not be enough. And you have all those experts. In terms of Morgan Stanley, we got an analyst. They have all the knowledge in their head. And writing the analyst report, they may not be quant. Right, so I think a combination of quantitative analysis with your fundamental research analysts, they have wealth of knowledge. That combination is really powerful. The question is, how do you leverage that, right?
Yeah.
So Javed, back to you then. How do you extract sentiment analysis from all this data, if it's structured or unstructured? But
so it depends upon the context. So if you use it, so it depends if you have enough data. First of all, you might want to use an off-the-shelf library or build your own models, depending upon the amount of data that you have.
Right.
You could use a data dictionary, but for the specific context. So if you're looking at financial statements, you might use Logarithm McDonald, or if you're looking at call transcripts, you might use Logarithm McDonald. If you're looking at sort of general or sort of social media data that has a lot of punctuations and adjectives and adverbs and capitalizations and it could have sarcasm and all that kind of stuff, you might use like a VATR sentiment, something that actually that takes into account more modifiers. If you're looking at a standard data set or you're looking for initial start, you can look at the Harvard Data Dictionary as well. So it all sort of depends upon the context. With the ESG that we spoke about earlier, you might want to use an ESG-specific data set for maybe every single sector. I think it all sort of depends upon the context. Yeah.
But is it sentiment analysis that we typically use NLP for, or is it broader? Like, are we going to find, actual, I guess, statistics or prices or different factors that actually could be valuable on their own, but they're not, say, structured in quarterly reports, but you could get them out of a conversation?
Yeah, so I think sentiment is one component, and it might be sort of straightforward. I don't want to sound too simplistic to calculate sentiment, positive sentiment, negative sentiment, net sentiment, however you want to do it. But I think, again, the novelty is in the skill of the researcher. So rather than looking at sentiment, look at language change, look at content change, look at things like how many digits are represented compared to letters. So that might give you an idea if management or whatever, are they actually providing factual information, or are they actually writing around what they're saying or what they're writing. So it all sort of depends upon, I think, the creativity of the researcher to try to figure out how to extract alpha. Can you combine, if you're trying to predict EPS beat or miss, can you actually look at sentiment prior to that, and can you look at some other sort of data set surrounding the reporting period? So again, it all sort of depends upon how you. I think a lot of it depends upon the skill of the researcher. Yeah.
Right. Okay. We actually have a question on Slido. I don't know who wants to get this one. Let's see. How much outperform could have been captured from just price target change, exclusive of sentiment? I mean, I get.
Actually, in our sector quant publication, if you guys want to read it, I'm more than happy to introduce you to her. Her name is Qin Yuan. So she did do an analysis that just by price targeted change itself, or just by sentiment itself, those individual two sets of data does not have enough signal, then you combine. So she did analysis of sentiment, price target change, and then combination. That gives you a much stronger signal.
Another thing you could do probably is also, it's a good way of doing it, is you can take price target changes and back test it and control for sentiment as well. So try to extract out the correlation between sentiment and price target change in your signal, and do a backtest of that too. But obviously I don't know the results, but that's one way you could do it as well.
Well, that brings the concept of regime that the earlier speaker was talking about. I mean, any of these things, it's a catalyst. Well, okay, well, what environment is that taking place?
Right.
Is it positive sentiment, negative sentiment?
Yeah.
I may flip it around using my former hat. Is positioning long? Is it short?
Yeah.
Those other contexts matter.
But it sounds like we're getting slightly better. Like we have good analysis under our normal quantitative work, and then NLP might just make us a little bit better, a little more accurate. Is that a fair assessment? I mean, Robert, you should take it. Like, is NLP really bringing value to, the industry right now?
Well, if I'll use our media consumption again as a bit of a metaphor. If the gold standard is being able to binge watch Game of Thrones at 30,000 feet, on your iPad, it feels like we may be late stage black and white, early stage color TV.
Yeah.
Well, no, that's actually, to me, is very encouraging.
Yeah.
It shows how much more we can go.
Okay. Yeah, I see somebody asking here, how do you deal with the potential issue of bias data? That's obviously going to, and can you deal with sarcasm or jokes? I don't know, Gordon, what do you think?
Yeah, I mean, that's a real issue, right? So, for example, imagine that you've got an army of humans who have scored a corpus of documents, right? And then you're then training on those human-generated scores. Those scores may themselves contain bias, right? So relatively simple bias, like, okay, are the scores generally more positive? Sort of an overall mean in the scoring. Those types of biases are easy to remove, what you might call sort of statistical bias, right? But what's much, much more subtle is, okay, so, and if you're evaluating the quality of the scores based on whether they can generate a trading strategy for you, well, it kind of matters a lot whether your strategy was long or short Volkswagen in 2008, and the people scoring those documents, the documents are necessarily in the past relative to the people scoring them. They know what happened to Volkswagen. It's a huge problem. It's not like the scores are in sample relative to the news items that the people scored them on. If you then backtest a trading strategy over that same period containing those documents, then that backtest is in sample as well, and you can't trust the Sharpe ratio of an in sample backtest.
So I can add a little bit. I think humans are inherently biased. We are biased, right? So what we did there for the sentiment analysis is for each of the records, trying to fight against the bias. For each of the records, we actually have 3 people to label it, right? And then out of the 3, let's say if they all say it's positive, then it's positive. If it's 2 people say it's positive, 1 say neutral, 1 negative, we say it's positive. And if all 3 of them say different things, we trash that record because it's not very useful. Sometimes what we find is for the same analyst team, we have them to label same sentence. Different people can think it's different. Some of them think it's positive, some of them think it's neutral, because the language is just so complex, right? It's not like social media, you say, I love this or I hate that. Financial language is just very hard to gauge sometimes in terms of direct sentiment. So you just have to really try your best to fight against that bias, but I think it's not that easy and straightforward to do.
Were you going to add something, Robert?
Well, I was going to pick up the can NLP deal with sarcasm or jokes, as it's got an upvote.
Okay.
I think to your point about I'll say it better be able to.
All right.
And to your point about your own internal data, a very rich treasure trove within certainly buy-side firms, less so sell-side because everyone's been scared to put anything down. There's a lot of sentiment and I think signal and information that could be gleaned from internal communications within a firm. And sentiment particularly, it's revealed through that sarcasm, through the jokes.
But you've got to be able to tell the difference between Ricky Gervais and Larry
Well, no,
David,
you
right?
absolutely do. But I mean, case in point, in February 2009, it was a bit of a stressful period.
Yeah.
And I had sent an email with a trader friend at another firm, and it said something along the lines, trading is hard, with another term in there. And 3 months later, I got a call from compliance saying, you can't say that.
Wow.
I'm like, look where we were at the time.
But I thought we were going out of business.
So, I mean.
Yeah, I also think when dealing with sarcasm and jokes, translations, it's very fragile, for lack of a better word. And it's context specific again. You may not get a lot of sarcasm in research reports, hopefully not.
Better be not.
Yeah, otherwise you get a call from compliance.
Right.
But in social media, you'll get a lot of sarcasm.
Yes.
But you also have to think, like, do you really have to account for sarcasm in financial research reports? Like, is there any data there that you're actually looking at in terms of sarcasm? Is it really significant? Translations are sort of a different problem, but that's sort of another thing. When you're looking at Twitter and whatnot, then that's something that's very context specific that you have to actually account for.
Yeah. I like this question, actually. Somebody's asking, what about not looking necessarily at sentiment, but about semantic analysis? So presumably the choice of words that people use more often. And is there a way to extract some sort of meaning out of that? I guess if people are using, I don't know, more financial terms, I think that was one of the earlier things, then maybe you feel they're more open and honest than if they're using more adjectives. Does anybody have a thought on that? Wow, we're stumped. Congratulations, whoever came up with that question.
I mean, one of the things we're trying to do in terms of getting semantics and relationship is really to work on ontology. I know, in the health industry, there are very good ontology for data scientists to use, but in financial industry, we have not found a good one. Maybe Ravenpack has one. Amanda, so I think it's important to create a domain-specific ontology in order for us to get semantic information and also relationship. Of course, without the ontology, you can do work, but if you really want to do a good job, you may need to have that.
Okay. But just back to data sets, because somebody asked about this. What about looking at things like patent applications and other governmental data? Are they helpful for finding trading signals?
You can look at patent data. We're looking at it right now. Healthcare, healthcare data.
Right.
But again, it's how you craft your signal. So you can look at first of all, do you have enough data? Patent data, likely.
Yeah.
But how do you craft your signal? Is it the number of sightings of a patent?
Okay.
Is it the sentiment of the patent?
Yeah.
What's your dependent variable? Like, what are you sort of training that on as well? So yeah, I think the next big push is looking at sort of custom data sets, whether it's like patent data or mining lease data. Like, a lot of mining lease data is published on websites. So can you scrape this website and get information on this this hole in the ground? I don't know anything about mining leases, but is there any way that you can actually use that context? So I definitely think so. It just depends if you have the data and if you're able to sort of scrub it and correctly sectionize it and tokenize it.
It really seems like there's still a lot of requirement for human oversight. Gordon, do you find that you have to really watch it and tune it and work on the model? And then how much bias are you applying to it by doing all that?
Yeah, that's a great question. Actually, it plays into something I wanted to say on the semantic analysis as well, right? So one of the great things that we're now able to do, and Ravenpack is able to do, is event detection, right? So does the news story contain various events? If so, are those events, do they fit into known types or categories of events, such as a disaster at the company's factory? And semantic analysis is quite important to make sure we're getting those right. So one example that came to mind was I saw a model that interpreted the news about the Amazon fire as well, actually, the Amazon Kindle fire was interpreted as a fire
in the Amazon,
which was bad. An actual fire would have been bad for Amazon, but in actual fact, they were launching a new product, which was good. And human oversight of these things is important. And I think in one of the talks, the speaker emphasized how important it is to sort of start off with an economic rationale that makes sense. Because again, otherwise it's extremely easy to overfit. One of the other questions on the board there was about, well, why can't we let the stock's reactions themselves score news items? And again, the answer is it's extremely easy to overfit these things, right? So surely it would learn that, having the word Lehman Brothers in the story is a negative, negative score. I mean, but it's just learning the history of what happened, right? So I don't think that's a good idea, because the techniques will simply overfit to the history. They're prone to that.
Tail wagging the dog as well, right?
Yeah, and so I think one of the best defenses against overfitting is to, before looking at the data at all, start with a hypothesis that makes sense, and then design a statistical. Look, this is called science. We all learn the scientific method in school. Yeah. You start with a hypothesis. You then design a statistical test, which can either confirm or deny your hypothesis. Then you apply your test to the data. So doing it the other way doesn't work.
Right. Is it a lonely job? Like, do you feel like you're in the office late at night typing away?
I mean, I have a team that I work with.
But it's lonely for them.
Exactly. But do they work as a team, or are they, is each individual person doing their own little effort?
I mean, it could be thought of as lonely in the sense that, I think to be good at what I do, you have to want to see the world as it really is, not as we'd like it to be. So, if you've put hours and hours of work into a model, you'd presumably like to see that model work. But if it isn't represented in the data, then you have to have the sort of psychological strength to say, even though I want the world to be this way, it's not that way.
Yeah. Anyone else have?
Well, yeah, I'd love to jump in, and I think it's scrolled off.
All right.
I don't know, it's still there.
Yeah.
It's and I'll take a slightly different view with respect to incorporating price in the analytics.
Please, yeah.
It's kind of central to one of the ways we used to look at the markets at both my prior places. What's happening now? When has it happened before? And what am I supposed to do about it? It's fairly standard problem, happens many times a day. There's a really big price move. Let's say Pepsi was down 4%.
Right.
And why is that happening? Typically, you do some sentiment analysis if you're looking at the news, pull it down. Well, the story that would get you to that answer the quickest in isolation might actually be flagged as a positive story.
Right.
Beat earnings, sales good,
Yeah.
something else was positive.
Sure.
But embedded within there is, and they revised something down.
All right.
So the context, that the price reacted negatively, the stock was down on the event, might reframe how one would tag that story.
Gotcha. Yeah.
And it's a good point. There's other stuff you can do. You can look at the excess return of that sector. Maybe there was something happened in the macro environment that actually has to do with that stock, so it's not all ideo. The other thing, one of the advantages of it is that you've never heard of Brexit until whatever 2015, 14, 16, whenever it was announced.
Election, but yeah.
So this way, you also hear about if you do. There's some advantages. I hear on the overfitting is a big issue, but you're also rather than coming up with a predefined data dictionary, you're also actually looking at the new nuances or words or terminology out there that are moving stock prices. So that's sort of another advantage of it.
Okay. I was going to ask about data privacy, and might some of these new data privacy laws impact your access to data, but it doesn't sound like any of you are really drilling into Facebook to figure out what's going on. Is that correct, or not so much? Like you're really looking at public information that you expect to remain public? Yes?
By design.
By design, yeah. Okay, that's good. So what about just sort of human-computer interaction in general? So I guess one of the points of natural language processing is to maybe let you talk to your computer, and maybe you could start doing Star Trek, computer, calculate this and tell me that and all the rest. Is that on the horizon? Anybody starting to look at being able to, improve the quality of the interface so it's quicker and easier for your analysts to start drilling into large amounts of data? Or is it still code all the way?
I think that's always a challenge. If you have a discretionary manager, a fundamental analyst, and you say, look, this 10K, there was a major change to this 10K from whatever last quarter or last year. Social, Google's being regulated, or whatever search is being regulated. We can take two vectors and calculate their distance and say there's a major content change. But how do you present that to a research analyst to say there's a major content change? So I think that's always very tricky to do. I think it's very powerful if you can solve that issue and to present it in a sort of a concise, meaningful, insightful manner. It's always hard to sort of present it to someone who is maybe not necessarily a quant, because it's not a signal, it's something that's live, it's in a report. And maybe Morgan Stanley has done it better. But it's in a report, you can use it, and is it usable? Because if you're looking at a fundamental PM, they don't care about the factor score or the exposure or the Z-score, whatever it is. They want to sort of see it in the text. And what you're sort of representing as a factor is not necessarily what's truly being shown in the text. So right. I think that's, if you can nail that, I think that would be a huge victory.
Yeah.
Yeah, I think that's extremely difficult. I mean, to your question of right. Can you ask machine pretty much to do anything you want to do? Mm-hmm. I don't see that. No. So take your example of, we have a lot of research reports, right? I'm on the technology side. One of our goals is to say, okay, can we allow our client to come to ask any question and we'll be able to find answer from the research report, right? Very good question. Can you do that? Answer is not that easily. So we create a digital assistant. We call it Ask Research. And so far, we're able to answer questions like, what is the price target or rating of Facebook? What is Tesla's revenue exposure to China, for example? Or can you send me Apple's model? Right? That's that kind of things we can do. But to answer the question of what is Morgan Stanley's view on U.S.-China trade war, right? It's very hard to answer. Why? What do you mean by view? Right? When I read the report, I know exactly what view is, but machine does not know. So, to the early question around semantic and all that, we believe, one of the ways to address those is really to create a financial ontology I talk about a little bit. And then with ontology, of course, the machine can then extract knowledge from reports and other news and then continuously learning. But the problem is creating ontology itself is a very, very time-consuming exercise. Not only that, you need an expert to do it, right? You need people who really know that knowledge to do that. So it's a pretty challenging thing, I say. And then one of the things we've been experimenting is to look at, is there any way we can semi-automatically generate ontology and not completely manually? So that's kind of things we're looking at. But I think it's a long shot.
There's a way to go.
Yeah.
Okay, we have about a minute left. Let's hit the last question. There's 5 people voting for this. Gordon, maybe you could take it. So how would you know whether there's alpha in the source of textual data even before building a model?
Well, my first reaction was to say, to some extent, the definition of a model is what connects your data to a prediction. So without one, it would be hard. But I mean, I do think there's this sort of unicorn that some people may believe exists, which is a sort of a pure AI that looks at all the data out there and then figures out trades to do. You know, and like I've never, to my knowledge, that's a unicorn at this point. I don't know of any successful large fund that's sort of a pure AI, right? So what that implies is that it always starts with some sort of trader's intuition. You know, like is there any reason to believe that this is driving stock returns? And you know, we more or less, you know, finance departments, people can get whole PhDs in finance on how information is encoded in prices, right? So that's a field known as market microstructure theory. Is how it governs the interaction of market makers and informed traders, and it has a lot of very good explanations on how new information ends up in the price, so the prices become efficient in reacting to new information. And so, you know, if you understand the finance behind how new information is reflected in security prices, then you can kind of follow that back and say, you know, does this appear to be that kind of information? You know.
And I would agree with Gordon as well, because especially what you said in the beginning, it depends how you define a model. So that an easy thing to do is to take a piece of textual data and create features out of it and backtest the individual features on a univariate basis. So forget about building a model, and forget about constructing a model to construct the features. So start off with sort of garden variety features that you can construct easily, and see if there's any efficacy in those features, in the backtesting of those features. And then you can worry about if you define depends how you define a model, then you can worry about whether you want to construct a specific NLP model to create a feature, or if you want to take all the features that you've created and build a model around those features. But I think that's sort of an easy way of, an easier, maybe quicker way of initially gauging the efficacy of the data set. Obviously, if you have all the time in the world, then it wouldn't necessarily matter. But that's one way you could do it.
Okay. Sounds great. Listen, I think we've reached our time, and we took most of the questions. Armando, do you think that was enough for questions? Yeah. Great. Well, listen, thank you very much to the panel. Thank you all. I appreciate your time.
This is Raven Pack.